In this presentation, we will talk about residential foundations. We're going to talk about the purpose of foundations, the design considerations, and types of foundations. And the types of foundations we're going to cover in this presentation are shallow foundations, spread or column footings, continuous or strip foundations, and slab-on-grade and thickened slabs. The purpose of foundations are to provide a level, stable surface to safely support a structure, to also transfer building loads to the soil, and to anchor the building and protect it from wind, flood, and seismic loads. Anytime you are designing a foundation, the following design considerations must be carefully taken into account: loads from the structure, allowable soil bearing pressure, frost depth, flood elevation, drainage, and cost. The foundation must resist a combination of design loads that are specified by building codes. Design loads include dead loads, which includes the weight of the building, live loads, which includes the weight of the occupants, furniture, and equipment, lateral loads, which includes wind, seismic activity, and floodwaters. Dead and live loads must be considered together. Dead and live loads will be transferred through the structural components of the structure to the earth, which will cause a soil reaction pressure. Some load combinations may actually cause the building to lift up from the foundation. For example, a load combination included in the International Building Code requires that only 60% of the dead load be combined with wind and lateral earth pressure. The wind and lateral earth pressure can cause a tipping effect on the building, which will increase the soil reaction on one side of the building, but may actually lift up one side of the building. The foundation must be able to safely transfer both downward and upward forces into the earth. Here are a few things you should know about allowable soil bearing pressure. It indicates the maximum pressure that the soil can support. It is typically presented in pounds per square foot. The different types of soils have different allowable soil bearing pressures. Information on types of soils present on a site and/or the allowable soil bearing pressure are available through many sources. However, since residential structures are relatively light in weight, an investigation of the allowable soil bearing pressure is rarely justified. Standard foundation types and sizes are based on local practice and minimum code requirements unless there are extenuating circumstances. For soil-bearing pressure information, a designer should refer to their local city engineering office. They may have unique requirements or building regulations that may need to be referred to, local or state building codes, preliminary information such as USDA Web Soil Survey, soil testing analysis, which includes site inspection and simple soil testing, and soil borings taken at proposed foundation locations. The freezing of a soil can cause a heaving of foundations. Silt or clay soils have a high water table and are highly susceptible to frost. To defend or combat frost heaving, a designer or builder should construct the base of the foundation below frost depth and provide frost protection for the foundation. Frost heaving, or a frost heave, is an upward swelling of soil during freezing conditions caused by an increasing presence of ice as it grows towards the surface upwards from the depth in the soil where freezing temperatures have penetrated into the soil. The image on the next slide shows the result of a frost heave on an addition to a building. The new foundation was placed above the frost line. When the supporting wet soil froze, the ice buildup forced the foundation to lift up, causing cracking in the walls and floor. Here you see the damage caused by a frost heave. Cracks appeared on the corners of the building and in the interior and exterior walls and ceilings and floors, all because of a frost heave. This is a frost depth contour map that shows the approximate frost depths across the United States. This frost depth contour map is only an estimate. The numbers under each state abbreviation represent the average frost depth for that state. The contour lines give a better estimate. Be aware that this map provides only an approximation of the frost depth. Local conditions will dictate the required frost depth. Local codes must be referred to for frost penetration requirements. An overwhelming abundance of floodwaters should be avoided. It can cause damage to the structure and damage to the contents of the structure. The height of floors are dictated by building codes and should be above flood levels. FEMA produces flood insurance rate maps which locate special flood hazard areas. Special flood hazard areas are predicted to flood during a 100-year storm. Those are areas that have a 1% chance of flooding in any given year. Base flood elevations are given on the flood insurance rate maps for flood-prone areas. A base flood elevation is the predicted elevation of floodwater during a flood and is used to design structures in those areas. According to this flood insurance rate map, the affordable home site is not within a special flood hazard area. To maintain proper drainage, the ground should be sloped away from the structure. Drainage pipes should be provided along continuous foundations. The ground floor should be located 6 to 8 inches above grade. A structure should always provide proper water drainage away from the structure. Here is an example of proper drainage away from a structure. Here are the types of foundations we will review: shallow foundations, spread or column footings, continuous or strip foundations, slab-on-grade and thickened slab. Shallow foundations transfer loads to the soil very near the surface. Shallow foundations include spread or column footings, continuous or strip foundations, slab-on-grade and thickened slab. Most residential foundations are shallow foundations. Those are foundations that bear loads onto the soil very close to the surface. A spread or column footing is a footing that spreads the load of the structure over a broad area. Uses of this type of footing are under piers or columns. A continuous or strip foundation or footing is a wide strip of reinforced concrete that supports loads from a bearing wall. Uses of this type of foundation or footing are under foundation walls. This allows for crawl spaces and/or basements. Slab-on-grade is a reinforced concrete floor supported by the grade or soil. Thickened slab is a slab-on-grade or soil with an integral footing created by thickening the slab, as shown on the image on the right. Uses of these types are when there is a shallow frost depth or when frost protection is used instead of a strip footing.